I see some people going back because they're just trying to get the answers. We know you have calculators. Nice job, Hanifa. Let's go. All right. I'm gonna. So, this is Carol. Right?
This is Brown.
Brown, got you. Check each other's work. Who is this? What's Nayland? Girl, expand this. What does this mean?
I was trying to do that, but I realized it wasn't.
If 2 to the third is 2 times 2 times 2, what is 4 to the third? About a minute left. Georges. You also got the exit tickets from yesterday?
It's on the slides.
Oh, it's on slides. Gotcha. Angel, you done? All right, go ahead and bring it back in 5, in 4, in 3, in 2, and in 1. Ding, ding, ding. Good morning, Brown. This is Brown, right? All right, so good morning, Brown. Oh, that's crazy. I want to take a very quick look at, can y'all see this? Y'all can see it now? I want to take a very quick look. This is Angel's work here. What step was Miss Georges talking about when she was going around? Well, she was going saying, I don't just want the answer. I want to show work. What work was she talking about? What step, looking at the model, was she talking about? Hanifa? The expansion step. What is this 4 called? It starts with the B. We know what the 3 is called. What is the 3 called? Exponent. What is the B called? I mean, the exponent. What is the 4 called? Do we agree with this? What is the actual value of this, though? Do we agree with this? Which is what? Do we agree with this? Which is what? Now, looking at part B here, let's just do this really quickly. What's my base for A? The quantity of -3. Why am I saying the quantity? Yeah, so this is -3 times, which is, so it can't be A. How about, what's different about B? He didn't circle B. What's different about B? I see Amy taking notes. What's different about B? A and B look the same. What's different about B? Okay. So what does this mean, actually? Is this what this means? Put an X here. That's not what that means. It's actually -1 times 3 squared. Which is why if you put it in your calculator, if you use parentheses, you'll see. Go ahead and everyone on your calculator right now use parentheses, -3 close the parentheses. We're using parentheses here. And I'm going to use the caret button. Y'all know where the caret button is above the division sign? And I'm going to square it. What should I get here according to my work? 9. What do you think is going to happen if I don't use parentheses? When I didn't use parentheses, did I get positive 9? When I did, you're not even on the right page, brother. I got negative 9. Is there a difference when you're using parentheses and exponents? Was there a difference in my parentheses when I use exponents? Yes, there absolutely was. This is crucial. Let's take a look at C. What's different about C? What's different about C? What's different about C, Angel? What's different about C? What's different about C? Yamika. And what else? Jadis, it's cubed. So my base here, should I use parentheses for my base or no? Should I use parentheses for my base or no? Yes. How many times is negative 3 going to be a factor here? What is a negative times a negative? I don't even need to do the math. What is a positive times a negative? Yep, Angel, nice job. Ooh, look at this one here. If this said negative 1 times 3 squared, what does this say? Shepherd. Does that negative 1 times 3 squared? 3 to the third. What is 3 to the third going to give you? What is 3 to the third equal to? 27. And we know negative 1 times 27 is going to be careful when you have parentheses versus when you don't. This is crucial here. Who is this? Oh, that's Emma. All right. Before we get to the meat and potatoes of the lesson today, y'all know y'all have a formative. When they taking their formative, Georges? Tomorrow, Thursday. We've been learning about systems. Oh.
All right. So, to make sure that we are successful for our formative coming on Thursday, and the reason why it's been pushed back to Thursday is because these next 2 lessons today and tomorrow are going to be on your formative exam. We want to make sure you guys are ready so you can be successful. But also, we want to make sure that you understand yesterday's exit ticket because you may or may not see on your formative exam as well. So there are students' work that we can look at. We're going to go over. This is from yesterday's exit ticket, question number 1. Jalen, can you please read out the sentence from the first problem?
No, because the dotted line is passing through it and it's not in the overlapping area.
So yesterday we were asked, is this point 0,4 a solution to this inequality? This student said no. What did the next student say? Emma, can you read it out first, please? The second student? No,
because the dotted line is passing through it. Dotted line means the point is not included with the solution, and it's not in the overlapping region.
So let's talk about what that means. When we talk about a dotted line, what inequality symbol do we use for the dotted line? What inequality symbols do we use for a dotted line? 3 hands.
If your hand's not up, you are looking around the room to actively help yourself.
You guys have your reference sheet and there's an anchor chart. Everyone's hand should be up. What inequality symbols do we use for dotted or dashed lines? Dotted or dashed lines? Amy, what does the anchor chart say? Greater than or? Greater than or less than. We're looking at greater than or less than. We do not have that equal sign on the bottom, so that means what about our answer choices? The answer choices are what? What do you know about the answers that are when you're talking about on a dash line? Those answers are what?
These,
Not included. It's not part of the solution. Think back to open circle versus a closed circle. So anything on those lines are what? Louder. Anything on those lines are what? Everybody. Anything on those dotted lines are not included. That's not everybody. So they're not included. So that point lies on a dotted line, which means it is not included in our solution set. It is not an answer to the inequality.
Ms. Georges, you're telling me because this is dotted, 0, 4 is not going to be satisfy this graph? That's what you're telling me, Ms. Georges? Got you, got you. But Emma, this is on our graph. How come this coordinate is not working? Yeah, it's overlapping, so it should be working, right? Emma thinks that this coordinate 0, 4 should be working because it's overlapping. Should 0, 4 work here? Yamika, why not? Oh, it's on the dotted line, which means, can it be a solution? No, because the line is not included. How can we tell that this is not included looking at the visual line? Haley? How can we tell this, all lines on this line is included, but not on this line? How can we tell visually that all of these points don't work on this line? Because it's what, Brian? Because it's dotted. We're going to come back to this. You're definitely going to see this on your exam on Thursday. All right, go ahead and flip the page. We're going to have a really good day. We're on the next page. We're on page 2. In the next 5, in the next 4, in the next 3, in the next 2, in the next 1. Whose work is this? My work. At first, I'm going to actually need a moment of silence because we are officially done with Unit 4, Systems of Equations. Clap it up for Unit 5. Who thinks they know what Unit 5 is going to be about? This is one of my favorite units of all time because it really does change the way the brain works. So today we're beginning Unit 5. We're exploring, everyone say exponential functions and exponential expressions. It's often useful to write them out in expanded notation or expanded form. Who can tell me what 6 squared is expanded? What is 6 squared, Skylar? That's not expanded. That's the value of 6 squared. What is 6 squared expanded? 6 times 6. Am I only doing 6 times 6? No. Go ahead and expand the rest. Go ahead and expand the rest of this problem right here and tell me how we can simplify this using one base and one exponent. 2, 1, 2, 3, 4, 5. Your work should look like mine. Raise your hand if you use parentheses. Could I use parentheses here? Yeah, I could do 6 and I could do easily. 6 times 6 times 6 times 6 times 6 times. Right? You could use the x's too. Do the same thing for this bottom one here. Take 20 seconds to do the same thing for the bottom one. How can I simplify, again, not to find the actual value, how can I simplify all these 6s so I have one base and one exponent? How could you simplify 6 times 6 times 6 times 6 times 6 to have one base and one exponent? What could I just write this as? Who thinks they know? I see Sage's hand is up. I see Shaylee's hand is up. No, you're not 6. Who can read it to me, Sage? What is the simplified exponential expression of 6 times 6 times 6 times 6 times 7 times? Say it, Sage. Is it 67? What is it? 6 over 7? What is it, Haley? Somebody help her out. She's very close. Skylar. 6 to the 7th power. Absolutely. Nice job. How can I simplify this bottom one here instead of doing 12 times 12 times 12? What could I simplify this as? Because I see on most of our papers right here, on Ashley's paper, she has 12 times 12 times 12. 1, 2, 3, 4, 5, 6, 7. What else could you do here? What else could you do here to simplify this exponential expression? Amy. 12 to the power of. The exponent does not act like a numerical value. It acts more like a direction or an instruction. On your own, I'm going to give us about 60 seconds. I want you to expand. Some of you might be seeing a pattern. Raise your hand if you're already seeing a pattern. Some of y'all seeing a pattern? Do me a favor. On your own, we're expanding here. I want, even if you see the pattern, expand and then simplify it. Thumbs up when you're done. Mm-hmm. Yeah, simplify this.
Careful, evaluate means to solve it. It's not asking us to evaluate, it's asking us to expand. Make sure you are expanding, we're not evaluating.
Yep, keep going. Nice job, nice job.
Expand.
Nice job. I love the organization I'm seeing as well. $30 seconds left. Yep, there you go. Yep. Oh, but be careful. Make sure you put this in parentheses. Because this is different from this. Because this is just 1 to the 4th power. This is 3 to the 1st power. Use your calculator. Prove it.
I know it's different, but how? How would it?
You do it on your calculator. You'll see how. All right, bring it back in 5, 4, 3, 2, 1. Take a look at Layla's work. I love that we're multiplying all the way through, even if you keep this in parentheses. I love this. 7 to the 5th, snaps or no? Right. What is the exponent of this 5 here? If you don't see someone, there's always someone there. We have 4 factors of 5. Beautiful job. X, don't get it twisted. The base, beautiful. She got 10. Snap it up if you got that too. Emma, you got the same thing? Emma, are you noticing a pattern that would make this easier instead of always having to write out all of our bases? Like, how could we have gotten 7 to the 5th, 5 to the 4th without writing all this out? Well, Miss George has got something to say.
I heard a beautiful statement from Skylar, answering your exact question.
Skylar, go ahead.
For example, the first one, you could just do 3.2. This is by the power of 1.
Oh, so you're saying like if I had x to the 3rd times x to the 2nd, that should give me x to the.
And even if you do solve it,
Oh, because you're adding. What is Skylar adding here? Yeah, so x to the 3rd times y to the 4th is going to be xy to the 7th, right? See xy to the 7th? Do me a favor. I want everyone to circle this, write these 2 equations, except for Layla because I have her paper. Write those two equations down. Write these two equations down. I love that we're on the next page, but you should write this down for me, brother. And believe it or not, this is actually incorrect. Skylar was right here, 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 here. What's different here? Oh, what are we're talking about? Louder. Yeah, louder.
They're different bases.
Different bases. So let's take what Skylar said and think. We can add the exponents of exponential expressions, but what has to be true about the bases? Something to think about. Turn the page, turn the page. What is the rule for multiplying exponential expressions with the what? With the same. What's the rule? What can we do? What can we do? What can we do? What did we just do on the previous page? Multiplying exponential expressions with the same base. What did Skylar say? What was the strategy? When using the, everyone say product rule. Everyone say product rule. Everyone say product rule. When using the product rule, you can add the bases or add the exponents? Add the exponents. All the time? Or only if what? Add exponents only if the bases are the same. So I wanted you to put a little note here. We said x to the third times x to the second is equal x to the, right? Because we have 5 factors of x. But we can't say x to the third times y to the second is equal to xy to the fifth. Put a little dash through that. We can't say that that's true. This is untrue. Why is this untrue? We just did it right here. Why is this untrue again, according to our product rule? Oh, Amy, they need to have the same what? Because that'll tell me how many factors of the base that I have. Because look. This really is x times x times x times y times y. I don't have just one x here, right? I have 3 factors of x, right? I don't have 5 factors of y. I have 2 factors of y. Look at the proof down here. We're multiplying exponential expressions with the same base. You can the exponents. Algebraically, this is what this looks like. What's my base here? What is my exponent here? Do I have 1 exponent or 2 exponents? Right? So because I have the same base, what can I do to my exponent, Sebastian? Yeah, I'm multiplying with the same base, right? And this would just be a m plus n. A quick proof, before we do this fraction piece right here, let's just rewrite x to the third times x to the second. Using the product rule, because I'm multiplying a product here, we know what my answer is going to be here. It's going to be x to the 5th power. Because what am I doing to my exponents, Kendry? What am I doing to my exponents, Kendry? I'm going to add, and what that works look like is x to the 3 plus 2 power. Because we know 3 plus 2 is 5. Who can tell me what my bases are here for this example? What are my bases here? What's my base here? Not a trick question, Shepherd. 1/3. What is my exponent of this base of 1/3 here? Daniel. Take 15 seconds. What do you think the answer to this problem is going to be, and box it? The answer. When I say answer, the simplified exponential form. You have 10 seconds to write what you think the simplified expression is going to be. Five seconds left. Yeah, simplify that. So one of the things I'm noticing on our papers is we're using the product rule here. This is really 1 to the 3rd to the 1 plus 4th power. Now let me ask you this question. Is my answer A, or is my answer B? Actually, take a look. Sorry, I saw C too. Why would a student get C? Why would a student get C here? It's going to be a multiple choice answer. Why would a student get C here? All right, so there should be a 1 here. So I always write my imaginary 1 in. So we know C is not correct. What's the difference between A and B? What is the difference between A and B? Turn and talk to your partner, 10 seconds. What is the difference? What do you notice? Skylar, what's the difference between A and B? Skylar. Just to clarify here, let's take a look at A. A is really saying 1 times 1 times 1 times 1 times 1 over what? Over 3. The only base here is the numerator of 1. Do you see that? In B, what is my base in B? 1/3. So this is actually 1/3 times 1/3 times 1/3 times 1/3 times 1/3. The answer is B. Please make sure you have these notes down. Parentheses is what trips students up the most in this unit. I have mad notes that you don't have on your paper. Yeah, did the base change? No, because it tells you the number of factors you need. Just like when we did x to the 3rd times x to the 2nd, it just tells you keep the base the same, but you do what to the exponents, Emma? Now let me all right, go ahead and do, actually you should be able to do this entire page in the next 4 minutes. I'm going to put 4 minutes on the clock. You are doing this page for the next 4 minutes. Page 4. I remember saying silent and solo. If you didn't hear me, I'm going to say it again. We're silent. We're solo. Thumbs up when you're ready to get checked. Come on, let's go, brother. It says try not to use expanded form. You don't have to expand. We just want to use the simplified version. It says don't use expanded form. Then keep working. Keep working. Let me see if you think you can start doing this. If you think for the product rule we're multiplying, we add the exponents. What do you think we're going to do for division? Not quite. No, I don't want them to use expanded form for this part. Nice job. I'm noticing most kids are done, so I'm gonna cut the time out about 1 minute. What else was I gonna ready to say?
Are you pushing them to show you the thing?
Which one?
Show this or no?
Yeah. Let's keep pushing that. Let's keep pushing that.
Practice, we want to see you show how you got this.
Got about another minute and a half left. Make sure you're showing if you're using the product rule what's being added, subtracted. Nice. All right, get ready to participate. Get ready to participate. All right. Go ahead and bring it back in 5, in 4, in 3, in 2, and in 1. Do we agree with 8/9? I mean, excuse me, 8 to the 9th power. Do we agree with 100 to the 13th power? Why is using the product rule good for problems like D? Why should we use the product rule for things like D? Because what, Amy? What's too much? It's 2,000 what? Factors of 2,000. I'm not sitting here writing 2,000 factors of x, but Emma still got x to the 2024th power, which is correct. What's wrong about B? I love the expansion, looks good. What's wrong with B? Look at her answer for B. We're looking at the board for the answer B, just like Emma is. What feedback would you give to a student like this? Yamika? Did you say low key? Okay. High key, it'll be 1, right? You need parentheses here? Because, Emma, you did this great. Your base is, how many factors of a denominator of 2 do you have? You have 6. The difference here, y'all, and we're not, are we doing this in 8th grade? No, we're not doing this in algebra. This is not the same as this. Because this is saying 1 to the 6th power over 2 to the 6th power. This is just saying 1 to the 6th power over 2 to the 1st power. These are not the same. When the base includes a numerator and a denominator, both have that exponent. All right? What was Amelia's issue on the bottom here? Yeah, we said we add the exponents. 3 plus 5. Yeah, this is correct. What's wrong? What's wrong? What's wrong, Soto? Oh, so it should be 16 to the 24th power. Yeah? She forgot a factor of, no. She forgot her factor of 16. 3 factors of 16 plus 5 factors of 16 plus 1 factor of 16 should actually give me 9 factors of 16. Go ahead and snap it up. Whose paper is this? Snap it up for Emma. Snap it up for Emma. Snap it up for Emma. I see some haters in the room. All right. So as we, let's do that. Yes. and save me some actions. No, Shay's gonna be fine. All right. As Sage is passing out snack, and we are silently eating snack, I'm about to put you on to even more game. Pete, go to page 5. I'm about to put you on. Before, because some of y'all are already like, oh, we're divided now. I know what the pattern is. But let's prove it mathematically. Let's expand my numerator here. What is my numerator going to be? Expanded. I see some of us are opening up our little baggies. Go ahead and do that. If you have your bag already, you should also be taking notes. What is my denominator expanded? What else, just to make things organized, could I multiply under these factors to keep this the same? 1. I'm just going to do times 1 times 1, right? Just to keep it organized, because do you agree that this is 6 times 6, Haley? Yeah. If we do 1 times 36, is it still 36? If we do 1 times 36, we're just trying to keep things organized. It doesn't change the value. What is 6 divided by 6? Where did this, what's 6 divided by 6? Appreciate you. What do I have left in my numerator here? What do I have left? 6 to the, 6 to the, 6 to the, 6 to the. And if you didn't have your 1s here, what would be in your denominator here? 0? 1. I just put this here just to show where the 1 comes from. This is 6 over 3. 6 to the 3rd power over 1. I felt like I did. You usually don't write that in, but I just showed you where these other factors are coming from. It's not 0, it's not nothing. It was just 1. So 6 to the 5th divided by 6 to the 2nd is 6 to the 3rd power. You should be thinking, what pattern? How do we get there? What I want you to do is I want you to do the same thing that we're using expansion. We're doing it for the first problem, we're doing it for the 3rd problem, and we're doing it for the last problem. You're crossing this one out. You have 2 minutes to expand. I'm going to do the first one with us. Make sure you keep your work organized. 6, 7. Haley, I'm not going to write my 1s. I don't need to, but know that this is 9 times 9 times 1 times 1. That's fine. You don't need your 1s here if you don't want to. If you have them there, that's perfectly fine. You can keep solving. Let's go, girl. Yep. Nice job. Yeah, nice job. Now let's divide. What's 9 divided by 9?
On 1.
Yeah, put your 1 down. What about this one? Keep going.
1. 9.
No, be careful. You can't do that because 9 divided by 1 is not 1. Yeah, keep going. Finish this up. Let's go. . The rule. Haley, 9 to the 7th power divided by 9 to the 3rd power. You got 9 to the... Seven to the 8th power divided by 7 to the 1st power is going to give me what? 7 to the...
Are you still asking me?
No. Ooh, this was a good one. What did we get for our final answer here? This is going to be what? What do you think this is going to be here? Go ahead and tell me. Layla, what'd you get? This one right here. Brian got it? Layla, what you got? 2/3 what? 2/3 and -2? Like this? Oh, you said 2/3 and -1. Like this? Is this what our answer should be? Should it be 2/3 and -1? Oh, 2/3 and -1.
2/3 and negative.
Take away the and -1 on top.
So somebody read to me what the answer should be. Hey, Brian.
2/3 to the power of -1.
2/3 to the power of -1. What rule are we using when we use the quotient rule? The product rule, we know what we did with our exponents. Who can give me a nice, clear sentence? What is the rule we use when it comes to dividing exponential expressions?
If it's a fraction or a negative number.
Well, what did we do? What rule are we noticing? What could we have done instead of expanding all the way down? What could we have done? Think about the product rule. What could we do? Who can give me a nice little sentence? Shepherd. When dividing, when dividing exponents, so dividing exponents with the same, what can you do? We can subtract what? Thank you, Angel. Thank you, Hanifa. Thank you, Emma. Thank you, Kendry. Go ahead and flip the page. Y'all, this is the rule right here that we literally just discussed. What's a quick proof that we can use? Well, we know x to the 5th over x to the 3rd is going to give me what based on this rule? X to the 5th divided by x to the 3rd should give me what based on the quotient rule? Skylar? Yeah, because what did Skylar do with her 5 and her 3? 5 minus 3 is equal to x squared. Why is it equal to x squared? Let's do one last proof, because x times x times x times x times x over x times x times x. What's happening to these x's, Brian? Why am I losing x's? Sebastian, why am I losing x's? Yeah. X divided by x is x. So how am I losing x's? What am I doing, Sebastian? X divided by x is 1. X divided by x is 1. X divided by X is 1. Can I cross this X out? Why not? There's nothing to divide it by, so this is X to the second power. Do me a favor. Turn to page 7. Look at Ricardo. Read this. What mistake did Ricardo make? What mistake did Ricardo make? Haley? Haley, what mistake?
Okay, listen. So for the base, he did 3 times 3 and he got 9. And then he added the exponent, so he got 10. So then he got 9 to the power of 10. But that's not correct.
So what was the mistake? I heard it, but you said a whole bunch. What should he have done with the bases, Haley?
Like left it alone.
Yep, Ricardo multiplied his bases when he should keep the base. Now we're only going to have about 3 to 4 minutes of independent practice time before we get to our exit ticket. Let's do this example together, then you'll do the you try, then you'll get to your own. This numerator is a group. Let's follow our order of operations. Somebody simplify the numerator for me, please. Use the product rule to simplify the numerator. That's a 7 to the first times 7 to the first times 7 to the second times 7 to the sixth. What is my numerator going to be here? In the exponent form. 79? Daniel.
Please use that key vocab word, power.
How did he get 7 to the 9th power? What rule did he use? The quotient or the product rule? The product rule. What's my denominator going to be here? Hands? 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 What's my denominator? Emma. Is this my final answer? Now what rule should I use, Sage?
Oh, I understand it now.
Write them out, write it in expanded form, and then divide it.
So Sage said, Mr. Lyons, I want you to do 7 times 7 times 7 times 7 times 7 times 7 times 7. Sage, you hate me? What? Low key? She did say high key. So look. Do I need to always write out and always expand like this? What could I do, Danielle? Oh, I'm sorry. I said Daniela. It's Danielle or Daniela? It's Danielle. Oh, I forgot the Ella. Sorry, Daniela. I'm sorry, Daniela. Do I have to expand like this every time? No. What could I have done with my exponents here? I could have done 7 to the 9 minus 6, which would have got me what? 7 to the... Oof. We got to get to the exit ticket. All right.
Rip it out, please, Haley.
All right, rip out your exit ticket. You're going to have 4 minutes to complete your exit ticket. Oh, sorry. 4 minutes.
1 and 2 have to be done. If you can do prefecture credit, go ahead and attempt it.
Sorry about that. Make sure your name and homeroom is at the top. Try your absolute best. You got 4. We got 4. You can use your notes. You can expand. You can do what you need to do. Try your best. Put it on mute and then next time we try to get an instrumental going.
Three is extra credit. If you get it, you get it. If you don't, that's okay.
Back up. Actually, do me. It seems like you got it. Start your mile. Do the first two problems of your mile. Sorry. Gorgeous. I'm gonna save these for me. I can help you grade those later. I'm gonna go get ready for my next session.